Hello everyone, in this video we will be covering on the topic of gradient of a straight line. The objective of this lesson is to learn how to find the gradient of a straight line given the coordinates of the 2 points on it. So in this particular diagram found on the right, we see that we have a particular line segment again. In fact, it is the same one from the length of line segment video. We are also given the coordinates of the endpoints over here. But in this lesson, we are trying to find out the gradient of this particular line. You may know how to find the gradient back in Sec 1 or Sec 2 already. However, the way that we are going to learn and to apply, is slightly different. We are going to learn a more efficient method in this particular topic. So with that being the objective of our lesson, which is to find the gradient of a straight line when we are given the coordinates of the 2 points, borrowing the diagram at the beginning where we are given this particular line segment. So similar to how we did our length of line segment, I'm going to label this point over here A that has the coordinates 3, 5, and this particular point over here B, -4, -3. Okay, but take note that we're trying to find out the gradient, not the length in this case. Okay, we are going to make use of the information that we have already learned back when we are in Sec 1. Okay, what is the gradient formula? I hope you're able to recall that to find out what is the gradient, which is the measure of steepness, it will be equals to rise over run. Okay, so where exactly is the rise and where is the run? The rise refers to the vertical rise over here. Okay, and then the run will refer to this length over here horizontally. So it's quite similar to our length of line segment where we're going to make use of a right angle triangle as well. Okay, but the way to find out the rise and the thing that we're trying to find over here is different, right? So we also find out the coordinates of this particular point here, which I will call C. The x coordinate will follow the x coordinate of A. Okay, and then the y coordinate will follow the y coordinate of B, that is -3. Right, so the next question that we want to ask ourselves is what exactly is the rise and what exactly is the run, because we're trying to apply this formula over here. So the rise will actually be 5 minus away -3, that is 8 units, and the run will be BC, which is 3 minus away -4, that will be 7 units. So now that we have found out what is the rise and the run itself, the gradient will actually be rise over run, so 8 divided by 7, or the fraction 8 over 7. So in this question itself, we notice that the answer is 8 over 7 and it applies to this particular line. Okay, and we know that this line is a positive gradient line. Okay, it is upward sloping, right? Or will the same way, that we have just done apply to a downward sloping line, which is negative in gradient? Okay, so we're going to take a look at that by using this example over here. So this point, I have called it A, which has the coordinates -5 and 3, and this other point has the coordinates 4, -2, and I have called it as B. Okay, so again, we are going to use our gradient formula that we learned in Sec 1. Oops, I'm sorry, didn't correct this. Okay, then in this particular, by using this particular formula, I will then determine our right angle triangle or form our right angle triangle by doing this vertical line down and then a horizontal line to the right. Okay, right angle triangle over here. So this particular point is what we call C, and it has the coordinates of -5 and -2. Okay, so the second question that we asked earlier on is what is the rise and what is the length? What is the run? So the length of AC would actually be 3 minus away -2, that is 5 units. And the run is 4 minus away -5, and that is 9 units. So now, what is the gradient? If we stick to determining the gradient to be rise over run, okay, then our answer would be 5 over 9. I'm not sure whether you're thinking what I'm thinking right now. okay, but 5 over 9 wouldn't be the correct answer, because right at the beginning, I have mentioned that this is a downward sloping line, therefore it must be negative in gradient. So what we have previously learned is that, okay, the gradient, if it is downward sloping, we need to intentionally put in the negative sign over here. Okay, so our answer for the gradient of AB would be negative 5 over 9. So the one on the left is not correct. The one on the right is the correct answer. So you may be wondering, okay, why is it so troublesome? Alright, why is it that I need to go and remember that upward sloping means positive, downward sloping means negative? Okay, is there a much more efficient way such that I don't need to go and think about the negative sign? Okay, is there a way such that we don't risk forgetting the negative sign and then getting our answer wrong? We want a more efficient method. We want a better formula. Okay, so let's take a look at what we have already done so far. This was what we got earlier on, okay, with an upward sloping line, right? And then the gradient, we have found it to be 8 over 7. How we got 8 over 7 was because the rise is 5 minus negative 3 over the run, which is 3 minus negative 4. Let's observe these values that we have over here. Do we notice that 5 minus negative 3, they are the y coordinates of the 2 points A and B? And then 3 minus negative 4, these are the x coordinates of the points A and B. Furthermore, we notice that if I were to look at this in this manner, okay, with the denominator being an x coordinate, 3, and then the numerator being a y coordinate, 5, 3, 5 is actually the coordinates of A. Likewise, negative 4 and negative 3, that is actually the coordinates of B. Okay, so we make that observation so far. In the numerator, they are the y coordinates, and the denominator, they are the x coordinates. And vertically, okay, we see that it is corresponding as a pair to the coordinates of the endpoints. Let's look at the negative downward sloping example. Okay, in our incorrect answer, okay, we see that we just adopted the rise to be 3 minus negative 2 and the run to be 4 minus negative 5. But what do we see over here? Okay, the numerator remains to be y coordinates, 3 and negative 2 over here. And then the denominator remains to be x coordinates, 4 and negative 5 over here. But there is a problem. Okay, when we checked vertically, right, 4 and 3, they are not the coordinates of any one of this particular point. Neither is negative 5 and negative 2. Okay, and this seems to be giving us the problem for us to not be able to get the correct answer. Okay, so looking at how, if we have gotten the correct answer, right, if we ensure that the coordinates are aligned, okay, so they correspond, meaning to say that if I'm taking 3 minus negative 2, 3 coming from the y coordinate of A, then in the denominator, it needs to be the x coordinate of A as well. So now I have negative 5 here and 3, that is the coordinates of A. Then 4 and negative 2, that is the coordinates of B. So that results in me getting the answer negative 5 over 9. Alright, so there are several observations that we have made over here. Let me try to summarize it here. So, given a particular line segment, regardless of whether is it upward sloping or downward sloping, so long as I have two particular endpoints, the coordinates of these two endpoints, in this case I have called this A and B with the coordinates x1, y1 and x2, y2 respectively. To determine the rise as well as the run, that forms a right angle triangle. My coordinates of C will be x1 and y2. The rise will be determined by taking y1 minus y2, and the run, we make sure that it is corresponding. So because it is y1 over here, it must be x1 over here. so that when I form my gradient, I'm able to see that I have a corresponding pair x1, y1 that coincides with the coordinates of A, and x2, y2 coinciding with the coordinates of B. Okay, so that is the gradient of a line segment or gradient of a straight line formula. So there are some questions that you may have regarding the formula, but before that, let me just summarize the formula over here. Okay, one question that you may ask is, can it be expressed as y2 minus y1 over x2 minus x1 instead of y1 minus y2 over x1 minus x2? The answer is yes, it can, because x and y over here, they are just arbitrary variables, and what is important, okay, is that we have the coordinates, okay, being corresponding. So x1, y1 must come from the same pair, okay, and x2, y2 must come from the same pair. It doesn't matter, okay, when given a certain point, which one is going to be x1, y1, which one is going to x2, y2. So long as you're given 2 points, one of them is going to be the x1, y1, the other one will be x2, y2. There's no fixed way of selecting it. Okay. Another question that you may have is, can I have the formula as y1 minus y2 over x2 minus x1? The answer is no, it cannot, because we already mentioned that it is critical that the x and y values are corresponding. So as mentioned, okay, this must form and relate to a certain pair of coordinates, and then this must also correspond to another pair of coordinates. Then lastly, another question that you may also have, can I have the x's on the numerator and the y's in the denominator? The answer is no, because it will not satisfy our understanding of gradient to be equals to rise over run. Okay, the way rise is being defined is such that it is vertical, and that relies on our y coordinates, if you look at how I explained earlier on. And then for run, we're looking at something that's horizontal, and that relies on our x coordinates. So therefore, our formula must be the y's in the numerator and the x in the denominator, and vertically, they must correspond to a certain pair of coordinates that we are given. Let us now take a look at some examples of how we can apply the formula that we have just learned. So in practice now 4, I want to just look at part B to demonstrate it to you. If I have the coordinates of the points H and K, like I mentioned earlier on, it doesn't matter which one is x1, y1, which one is x2, y2, so long as you're taking from the same pair. So the gradient will be equals to -7 minus -2 over 5 minus away 0. And that will simplify to be -5 over 5, or you could just press your calculator directly for the answer to be -1. Okay, so we observe that in this pair over here, vertically, we have it corresponding to the coordinates of H, and vertically comparing this, I will have the coordinates of K. Okay, in between it should be a minus sign, because that is what we have understood, okay, of how we derive our formula. Right? Taking a look at another example, in practice now 5, the question says that if the gradient of the line joining the points 4, -9 and -3h is -3, we want to find the value of 3. So applying our formula, our gradient would be equals to -9 minus away h equals to 4 minus away -3. So it is always corresponding, and that will simplify into -9 minus h over 7. Question has mentioned that the gradient has a value of -3. Okay, so we can form the equation as such, and then we do our cross multiplication to figure out what is the value of h eventually. That will be equals to 12. And with that, we have come to the end of this particular lesson's video. I hope that you are able to understand how is it that we find the gradient of a line, okay, given the coordinates of 2 points. We will be looking at other kind of examples when we see each other again in our next lesson. See you!